We'll start in a minute, okay, guys? We're just
Yeah.
having some issues with the
Okay, so
presenter.
I'll introduce you, Fred, since Belle is having trouble with the audio. Well, Fred is an expert on mobile engineering, and today he's going to talk about Apple Vision Pro. And today we have the honor of having some guests that are not from BEON. We usually do these things for BEONers, for people who work in BEON.tech. But this webinar is open to the community, so we can all share the Fred's expertise and learn from him. So thank you so much, Fred, for giving this webinar. And thank you all the people that joined, that registered to participate today. And thank you. Let's begin.
Okay. All right, guys. Welcome to the webinar. I'll be talking about the Apple Vision Pro and what to expect from this new technology as a developer. Okay. First of all, I'm going to talk a little bit about myself. I started working with iOS development since 2012. So I've been on the road for quite a while now. I'm currently working as iOS engineer for Adapt, which is a North American consultancy company. And I've always been fascinated by mobile development. I remember today when I saw the first iPhone, and I knew it was something that remarkable that would change humankind. And today, everybody has their smartphone. It was a real game changer in our lives. And since then, I've been studying mobile development, specialized in iOS development. So here today, I'll be talking to y'all about Vision Pro, the latest Apple product. Just to make everything clear, I'm not talking about VR headsets. I'm talking about Apple development. I'm talking about Vision OS. So we won't approach much into Quest 3, Quest 2, or any other technology. We will talk about this new era of mobile development. Okay. So what we are actually going to talk about. So our agenda is first, I'll talk about with y'all about mobile development history. Okay, we're gonna go and look behind us just to understand where we are. And then I'll be talking about spatial computing. What is spatial computing? Uh, what is this new era of development? What should we expect from it? And then we're gonna go, what is Apple Vision Pro? It's not a merchandising, it's not anything related to Apple, it's just what this new product bring us. And as a developer, how can I prepare myself to understand this new reality, this new technology, this new product, okay? We are going to talk about the current user layout guidelines, just so we can understand as a layout for this thing, this mobile, what do you use today? And then we're going to compare with the Vision Pro layout guidelines. So the spatial computing guidelines. In terms of layout, what is the difference between what we have right now and what we expect to have in the future, okay? We're also going to talk about a very curious hypothesis of the uncanny valley. Don't worry, we're going to talk about it. I'm going to demonstrate a little bit of code, okay? So you guys can have a taste of it, can taste how easy, maybe easy is not the right word, but how chill it is to code for Vision Pro, okay? And then we're going to have an open question. So if you have any questions, I'll happily answer them at the end of the presentation. All right. So let's talk about a little bit about the mobile technology history. Why we're going to talk? Because in order for us to understand where we are right now, we need to look back and see where we came from. Okay, so we can see the evolution of the technology into today. Okay, so I didn't separated all the points of a mobile history with Graham Bell inventing the phone. No, I just got the milestones the remarkable milestones we have and pointed them over here. All right. So the first milestone I like to say is when Motorola creates the first mobile phone in 1973. That's when Motorola said, "Hey, community, we made a telephone that you can use and it's not attached to any wire. And within a special radio frequency, you can communicate with any other endpoint in the world. In the world, that was the first milestone. We can say, hey, this is a mobile phone. This is a cell phone. Yes, you can say that. That's the big brick phone, the big one that the battery was 90% of it. It weighed, I don't know, like a kilogram or maybe more. And then, but it was only 10 years after Motorola presented the world with a first cell phone that Motorola started to commercialize it, to sell the first mobile phone. So we do have a gap over there of 10 years. And it was only 10 years later that mobile phones started to exchange data. And that was achieved by the IBM Simon in 1993. Okay. And it was also in 1993 that Japan presented the world the first phone that could take pictures. All right. So that's a remarkable milestone because humans, the community learned that, okay, this is not made just for making phone calls, just voice calls. We can exchange more information using this network. And then, of course, mobile phones, they progress a lot. They made a lot of progress. Technology went pretty well. But there's another milestone we definitely need to consider, which is in 2007 when Steve Jobs introduces the world the first iPhone. Hey, Fred, you're not going to talk about Android or anything. Okay, there's a lot of terms, there's a lot of points, milestones I'm gonna talk here that it's going to be related to smartphones, but I will relate to the iPhone. Okay, iPhone was a really game change, a really big game change in mobile history because Steve Jobs introduced a phone that it was small, it had great internet connection. You could communicate with at that time high speed internet. You could connect to the Wi-Fi easily, and you had a remarkable touch screen. That was one of the best technologies introduced by the iPhone. Okay, we do have iPod Touch before that. Microsoft tried a few one phone before the iPhone, but the one that really worked and that had massive adoption was Steve Jobs with the iPhone. Okay, so when we look at the history, this is the history of the phones itself, smartphones itself. But we're talking about development history. And in order to talk about development history, we need to also talk about two guys that were really important to mobile developers. And these two operational systems, Symbian and BlackBerry, they were major at their time. Okay, they were big guys at that time. So in 1997 into 2013, we had Symbian. Who never had a Symbian? The N95. Every Nokia cell phone ran on Symbian OS. Okay, Symbian reached over 60% of the market share. It was huge. Every major manufacturer had Symbian OS running on their phones, especially Nokia. Okay, Symbian was created by a partnership between a company called Symbian and Nokia. So it was, and Symbian was pretty good because uh, mobile operation systems, they had other challenges than computer operational systems, such as they have to run on low energy consumption. you don't have many resources available, so you don't have enough RAM memory. You don't, if you use a lot of your processor, you're going to consume a lot of energy. And even today, you can say, oh, but my iPhone or my Android, it has 16 gigabytes. It has a Snapdragon processor. It doesn't matter. We still run on batteries, and our battery technology is pretty old. So those operational systems, even today, they can't, they have to use their resources differently. And Symbian did that very well. Okay, so so Symbian started to decline with Nokia's adoption of Android. Of course, these two guys, Symbian and BlackBerry, when the world started to see what the iPhone and what Android devices were capable of, they couldn't handle this change in the market. BlackBerry tried uh, to survive by changing their market to security phones. Even the U.S. government was using Blackberries in the last decade, but unfortunately, BlackBerry didn't survive as well. So BlackBerry was also an important player in the past. It reached over 20% of the market share in 2000, but it was more focused in business and enterprise sectors, right? It wasn't very popular. It didn't have a massive adoption for the BlackBerry. It was only businessmen that used to use BlackBerry because it was really easy to read emails, easy to use. So a lot of businessmen they used BlackBerry, uh, but it started to decline as well with iOS and Android because they were two operational systems that they had a better interface. Okay, Blackberries, you had that massive keyboard in front of them that occupied maybe 50, 60% of the front of the phone. Okay, and then when they tried to change their phone, it was already too late. Android was already getting popular. It's a really awesome operational system, and the iPhone was a really good phone with an excellent operational system running, and it was too late for BlackBerry. Okay, so they closed in 2022. They just recently went out of business. Okay, so when we talk about mobile development, I like to split the mobile development into three eras. Okay, the first one I like to call them the early ages, the first PDAs. PDAs is personal digital assistant. It's when you had a smartphone, you can call it that like that, where you could already exchange some data over there. You can already access maybe a browser, maybe your mailing, your email account. So at the early ages, there was quite a few issues with those smartphones. They lack of internet connection. Okay, they used to use that edge technology, 2G internet technology. It was really bad. Even in first world countries, you didn't have internet everywhere. Only a few places you could have a good internet connection, and those lots of paid SDKs. What does that mean? So if I'm a mobile developer and I wanted to develop an app for Symbian or for BlackBerry, for Symbian, for example, I needed to pay to develop it, even if I don't release the app. Just for me to have access to the SDK documentation, I had to pay, and each manufacturer had a different code, a different SDK. So if I developed for a Nokia a Nokia phone, another Nokia model might not run my code. So my app, I had to change my code. I had to change my SDK settings. I had to change a lot of stuff just to run in another device. So that disencouraged independent developers. Okay, but we reached the iPhone era. Okay, so it's the second era where it's perfect for independent developers. Now we can develop for free I mean, you do have to pay $99 to publish in the App Store, and I think it's $25 at Google Play. But in order for you to start your project, to code, to learn how to code, it's free. Okay, you can start doing at any time. So it's perfect for independent developers. Okay, you have high level languages. While in the early ages you had to deal with C, C++, right now you have to deal with Swift, Kotlin, which are very easy to read languages. They are very verbose, and they have an awesome garbage collector system. Their memory management, it's really good. So that also helps independent developers. Okay, you have easy internet access. What do you mean? You have 4G and 5G network out there, out of your house. You have Wi-Fi connection everywhere, and as a developer, you don't need to worry about if your app is connected to a Wi-Fi or if the Wi-Fi signal is weak and you need to connect to a 4G network. It doesn't matter. The operational system does that for you, and you don't even need to know about that. Of course, if you're dealing with package transfer, if you need to download the file or allow large amounts of data into your app, you might want to check what network you're connected to, but you don't need to. The OS handles that for you, which is really good. And you also have something that sometimes we don't realize how powerful our smartphones are. We have easy sensor readings. We can read GPS location. We can camera is kind of a sensor. We have accelerometer. We can know the position and where your phone is faced. You have infrared sensors, so you can use it. There are some apps out there. You can search for Air Measure, which is a really good app where it uses the most of your sensors. You can, for example, detect if your iPhone is touching metal or not. It's amazing. So in the iPhone era, developers can make use of these sensors very easily. I don't need to understand how the GPS chip works inside an iPhone or an Android to use it. All I have to do is to know the technology. So just assign protocols, add a framework, and the operational system will start giving latitude and longitude. So it's easy for you to handle sensor data. And there's almost no manufacturer difference within the same operational system. So if I code for iOS, there isn't much difference between my code if it's running on iPhone 8 or an iPhone 11 or iPhone 15. We do have to take care about operational system versions. So maybe I need to worry about something that it's not available for iOS 13, but it's available for iOS 15. But still, it's way easier. It doesn't give us the headache the early ages used to give us. Okay, so there are three mobile stages, okay, mobile eras, and the early ages and the iPhone era, which we just talked. And now I'll present to you guys the third era, the spatial computing era. Okay, and the best phrase that interprets that says what is the spatial computing is, what if I give you the Harry Potter wand as a headset? Why? What does that mean? Well, imagine if I give you the Harry Potter wand and only you could see what it plots in the world, what it inserts into the world. So if you had the wand and you're looking at your white wall at your house and you say, no, I don't want to see a white wall. I want to see just as if my house was a castle. And then in a like a magic, you start seeing rocks, you start seeing paintings, you start seeing swords in your wall. That's what it's closest to magic what we have right now. Okay, what I'm saying is now we don't use only now we're not only using a screen, a device, but now we are using our surroundings. Reality starts to bind into the digital world. That's where we are right now. That's the new era that's about to start. Okay. So, what exactly is spatial computing? It binds the real world with the digital world. Your surroundings becomes your screen. Elements on your screen now can react dynamically to light. So you can cast shadow, you can see reflection on your views. It's just not a solid color in your view and that's it. No, now your view can interact with the lighting in the world. If there's a light here and you're seeing your view, maybe from where it's your light, you can see kind of a shadow on the ground that it's actually your view or any digital element that's present that it's only present in the digital world. Now it binds with the real world. Okay. And now views now can go beyond a simple form style. Okay. Why do I say a form style? Form style is just it's basically everything we do on our smartphones. That kind of triggers me because every time a UX gives me a screen to develop, all I see it's a form. It's what is a form? You have labels, you have inputs, you have text fields, so the user can add their input. You have picker views, you have drop downs, you have radio buttons. It's all forms. It's all about user interacting to input an information. Now it's not only that. We don't need forms right now. Of course, it's way easier to use. Our mindset is it's still focused in form style views, but now we can go beyond that. Instead of having a button that I don't know, it adds something to our screen, why not plot a table in front of you where you can grab a thing and see with your own hands what you're doing? Okay, so, and when we talk about spatial computing, we need to talk about two really important concepts. The first of all is augmented reality, AR, and the other one is virtual reality, VR. Okay, so AR, it's when augmented reality, it binds the real world with the digital world. Okay, you can see both real and digital world. All right, AR users can control their presence in the real world. Okay, so if I'm using AR, I can see my surroundings. I can interact with the real world. Okay, you can achieve AR with a smartphone. You don't need to have a headset to achieve AR. Okay, I'm gonna show you some examples. AR, we have to understand that AR enhances both real and digital worlds, virtual worlds. Okay, and what about virtual reality? What exactly is virtual reality? Virtual reality is completely virtual. You don't see the real world. Okay, you might be immersed into a different spatial area, but it's all digital. Okay, that's virtual reality. The user can't see the real world, it only sees the virtual world. VR requires a headset device, either a Quest 2, Quest 3, the Sony headset for PS5, or Apple Vision Pro. But in order for you to say that you are in a VR world, you need to have the headset. Okay, and VR only enhances a fictional reality. Okay, it doesn't really exist. You don't really see the world. You are immersed in another dimension, maybe. Okay, so these are examples of AR and VR. You can see here, if you go to your smartphone right now and type lion, okay, at Google, Google will give you the opportunity to see a lion in the AR world. Okay, so in this example, plotting, I'm adding a lion in my living room. Okay, but the lion, of course, is not in my living room, but it binds the real world, which is my living room, with a digital world, which is the lion. Okay, so over there, the iPhone started reading my floor, my walls. It started to measure the couch, and it had a notion of height, width, and length. So the iPhone knew the distance between the floor, knew the iPhone knows the size of the lion, and then it can add within a real scale lion in my living room. Okay, so that's AR. And in the other side, in the right side of the slide, you have an example of virtual reality. So that guy is using a VR, that's the Quest 3 VR. And on the left side of the video, you can see that he is only seeing a digital world, a virtual world. Okay, that means that he he can change between VR and AR. Even on the Vision Pro, you have a kind of a button on the top where you can switch between immersive experience, such as that one where you are in the VR world, into a AR world. Okay. Right now, what he's seeing, he's in the virtual reality, and on the left side, you can see what is AR, augmented reality. All right. So let's talk about business. What exactly is Apple Vision Pro? What should we expect from it? Okay. So Vision Pro is a first generation device that Apple is releasing next year. Okay, it will be released, if I'm not mistaken, April in United States, and Apple only said, okay, in a few more countries in 2024. We won't tell you when, but it's going to be in 2024. That's what we know. Okay, so Apple calls it not a headset, not a VR headset, but a spatial computer. Okay, that makes us with the MacBook. So if you look into your MacBook using the Vision Pro, it already identifies that MacBook Pro, it's yours, and a button on the top of your MacBook appears. And if you look at it and do the like this in your hand, it will select that button, and then your MacBook screen starts to appear into your Vision OS. I don't want to say screen because it's not a screen. It will appear in your Vision OS surroundings. Okay, so basically that's it. It's a spatial computer. It's going to be a work tool, and it's more of a use at home gadget. Okay, I'm not expecting to see anyone walking around the street with that thing, especially because it's a extremely expensive device. To be honest, Apple really Apple makes beautiful gadgets. iPhone is a beautiful smartphone. iPad's really nice. MacBooks, they're awesome. But to be honest, in my opinion, Vision Pro, I mean, it's not pretty, man. I don't know. It looks like swimming goggles. I don't know. I think they tried their best, to be honest. But again, it's a first generation device. So just as when Apple released iPhone, uh, a few time after the iPhone release, they released the iPhone 3GS, which already contained some hardware upgrades, and they already got some feedback from the users, and they improved their hardware, their device itself. So we can expect some issues with Vision Pro. I'm not saying it's not worth; it's definitely worth. It's a really good tool, but it's a first generation device. Okay. So it's going to be a use at home gadget. I don't expect to see people using it on the street, especially because the battery is not that good. again, battery technology is something old. Every single industry is struggling with battery. All right. So, what else should we expect? One thing that I need you all to understand is that there's no video of someone using it yet. All right. Only a few people that had a chance to use it, they are reporting their statements into YouTube videos, into documentation, articles. So they are all everything we had about we have about everything we know about Vision Pro. It's only based on a few people's statements and also about through Apple's documentation. All right, Apple already released a huge amount of documentation about Vision Pro. Okay, about their layout guidelines, about which frameworks you should use to code with it. You can already download the Xcode beta to run your Vision Pro simulator. Okay, so we can already have a notion. We can already have kind of a sense of what is Apple Vision Pro. But one thing you guys need to keep in mind is no one is really using it yet. Okay. Uh, Also, Vision Pro they introduced new layout guidelines. We're gonna talk about it again later. We will see that some types of screen measurement, sometimes of screen elements such as buttons, navigation bars, they changed now. The background changed now. The color usage changed. All right. So another thing that we need to keep in mind is Apple Vision Pro doesn't use any controllers, no controllers at all. All interaction with eyes and hands. Okay. So what does no controllers mean? No controllers, it's because the previous versions, the VR's headsets we have today, they do need to use some controllers in your hand to use. Quest 3, apparently they introduced a technology where it understands your hands, but Apple Vision Pro, you don't need controller. You can connect your PS5 controller to your Vision Pro headset so you can play a game. But again, you don't need to. Okay, it's all about hand. You can either touch a button. If a button appears in front of you, you can just touch it, or you can just look at the button and do like this with your hand, and then it will select your the button or anything else. Okay, what is selected. One thing that I really need to talk it's about the eye tracking. What exactly is eye tracking? So there's a really good phrase that makes us understand what is eye tracking, which is the mouse made the MacBook, okay, the Mac OS, the Macintosh, all right. The click wheel made the iPod. I don't know if you guys remember there was that wheel where you could slide your finger on it and you could select things on your screen. That made the iPod, and the capacitive touch made the iPhone. The really precise touch, the drag, the pinch, all those gestures made the iPhone. And what the community is saying is the eye and hand tracking, it's going to make the spatial computing world. So in order for you to interact with the world is when you use your eye, okay? Uh, there, how does the eye tracking actually works? So it tracks your eyes through infrared sensors and cameras. So when you put your Vision Pro headset, you can there are a few cameras and sensors that looks into your eye and know which direction you're looking at. And then when you look into a button that appears right in front of you, that button, the OS knows that you're looking at that button, and it starts to change. It makes a hover effect. Okay, testers stated that's really impressive. Okay, you can search around the YouTube. I can give you my sources after the webinar, but everybody that used the Vision Pro stated that it's just impressive. There was this YouTuber that said it's the closest thing to magic I've ever experienced. It's just amazing. And also, there's a tweet of a neural technology engineer from Apple that stated that the coolest result involved predicting if a user was going to click into something. So we're going to talk about the sensor readings on the Vision Pro, but the Vision Pro uses a neural network. There's a chip called R1 that it's a specific. It reads the sensors of the Vision Pro, and it focus on. It has all the processor available, the processing available, just to understand and predict if you're gonna click on something or not. So people are amazed how accurate it is, the eye tracking. How can you look into something and it knows you are looking at it, and it knows you are going to click at it? Because if you think about it, it's a camera and an infrared that's looking right into your pupil, okay, right into your eyes. So it can get micro movements of your pupil, of your eye. So it knows when you're sensing something. It knows when you're about to experience a change in the screen, even before you click. So it can already handle, it can already process something even before you do it. It's amazing what Apple and people are disclosing about the eye tracking. Okay. So basically, you move your eyes to select things. Okay, that's the eye tracking. And another really cool thing is the pass-through vision. So what is the pass-through vision? The headset itself, you can't see the user's eyes from the outside. Okay, if I'm talking to someone that's using the Vision Pro, I can't really see their eyes because there is a screen. There is the Vision Pro in front of it. But facing the outside world, facing the case of Vision Pro, there is an OLED screen facing out that reproduces the eye for the external world. So if I'm using the Vision Pro and I'm working with views on my surroundings, if someone comes to me and wants to talk to me, I can push a button and then I can see the user, and the user will see my eyes. But the user is actually seeing a screen that reproduces my eyes. Okay? So how does Apple Vision Pro actually work? There's a lot of sensors here. Okay? We do have downward cameras, infrared illuminators, a LiDAR scanner, a true depth camera. There's basically 12 cameras facing out, two cameras facing your eyes, looking to your eyes. There are bunch of other sensors, two infrareds for each eye, a lot of infrareds to understand the world, and the LiDAR scanner, which is one of the best technologies in my opinion, which is a light detection and ranging. So it knows, it can measure distance, it can measure light effects, just really awesome. Okay, so you can expect something that it's going to have some weight. Okay, it will weigh something, but again, Apple also focused into comfort. All right. So inside of it, how does it track your eyes? How does it really works? Uh, it's facing. There are two screens, for one for each eye. Okay, inside of it, these screens, they have a resolution higher than a 4K. Apple states that for H64 points in an iPhone 15 screen, you have 1 point in the Vision Pro. So it's a really good image quality you're going to see in your eyes. Okay, and also there is no delay of when you look into the world and the the Vision Pro camera capturing it and passing and showing it to your eyes. Okay, and we also need to talk about the hardware. All right, it's not running on an iPhone chip or a Snapdragon chip. It's running on two chip architecture. The first chip is the M2 processor. Yes, the same M2 we know, the Apple Silicon chip, where you can where the M2 provides a phenomenal performance at a low energy cost. It doesn't heat that much. Okay, so and the M2 will be focusing only on processing apps, processing data. All right. That's the main responsibility of M2. So you have a really powerful chip over there just to process data, just to process the app, the operational system itself. But since it's two chips, you have a new chip which is called R1. It's also an ARM-based architecture that it handles sensors. Okay, R1 it's just to process sensor data. So all these 12 cameras, a bunch of infrared systems, they all need to make a complex calculations in order for you to obtain a result, such as distance, such as a mapping of the world. Because the way the Vision Pro works, it kind of map everything around you. So if, for example, if I add into, if I'm using the Vision Pro and I ask Vision Pro to render a 3D object, okay, let's say a rocket, a small rocket on my hand, and I get this rocket and put on my table, okay, above my table. If I go to another room far away from my table and look into the direction of my table, and if I don't see my table, I won't see that 3D object. It knows where you are. It knows your surroundings. It knows what you're doing. Okay, so in order to process all those data, we need a specific chip for that, and that's the responsibility of the R1 chip. Okay, this architecture reduces lag and delivers an amazing performance. All right. What is this lag? It's like if I'm looking to something in front of me, and I look into another position, another place, there won't be a lag between the Vision Pro camera looking at this side and looking to the new side. You are not going to notice any lag or anything like that. It's just impressive what Apple did over here. All right. So, how do I develop for it? Okay. We talked about the hardware, what it's capable of, but as a developer, what I need to know. Okay. First things first, Apple silicon chips only. Uh, Apple was having a lot of issues with the Intel-based processors, all right? When they started to release, when they announced the Apple Vision Pro, 2 weeks later, they started giving the SDK and the beta versions for the Xcode, and everybody could run Intel-based MacBooks, iMacs, Hackintosh, whatever. If you had Intel-based processor, you could run the simulator for Vision Pro. Okay, but they were having a lot of issues. It was crashing a lot, so they decided to stop giving support for the Vision Pro development into Intel processors, and now it only works for silicon chips only. So M1, M2, M3, those kind of processors nowadays. All right, that's the first red flag that Apple will stop providing support into Intel-based chips. Okay, the community was expecting the new OS after Ventura. I don't remember the name right now, but the new operational system from Apple to Sonoma, the Sonoma operational system to to not support Intel-based processors, but they released it for Intel processors. But that's the first red flag that Apple will stop giving support to Intel chips. Okay, probably after Sonoma, I don't think we're gonna have an operational system that handles those Intel processors. Okay, but that's my opinion. You also need to learn SwiftUI. So if you want to interact with the Vision Pro, it's 100% SwiftUI. Okay, if I want to make a screen, if I want to make a form, if I want to plot anything, it's all about SwiftUI. SwiftUI, it's the evolution of UIKit. All right, it's a reactive way of programming, of generating your interface. Really cool, really performatic. Okay, it's reactive, so it's powerful for the development. Okay, so you will use ARKit to manipulate your surroundings. Okay, so it's important to know AR. But if you really want to learn how to code in for Vision Pro, you need to use the Reality Kit framework. Okay, it's an Apple framework. It's really good. It's been around even before Vision Pro, and it actually handles the physically based objects. Because now virtual objects, they need to have real world information. So they need to know their mass, their size, their height, their length, their format. And Reality Kit actually helps to make all this calculus. Okay, so even if even the pattern or the texture you're using in a virtual object, that texture behaves differently with uh, uh, different types of lighting interferes into the pattern or the surroundings of the object. Okay, Vision Pro will also have Unity support. Okay, so you can create a game or an app using Unity and release it to Vision Pro. But that's something really new. Okay, only I think it was I think it was this month, November, that Unity said, "Hey, okay, this is the first beta of our framework that we run into the Vision Pro. So it's in its early stages. Okay, I wouldn't even call a beta. It's too early for you to bet on this technology for Unity. Okay, it's too early. But you can develop amazing things using ARKit and Reality Kit. Okay, with SwiftUI. All right. So one thing that Apple really handles very well, it's privacy. Okay, it started with their with a lot of their politics, such as the Apple tracking transparency, which if you don't want to the app to track your advertising data, you don't need to. If you want to use the camera, you need to ask for the user's permission. If you want to use the GPS, you need to ask for the user for permission. And since Apple takes the privacy very seriously, it wouldn't be different for the Vision Pro. Okay, so the app must request access to access hand tracking data. Okay, so click, which is basically doing this with your hand, looking at something, doing this. Apple, you can do that without requesting the user permission or anything. But if you do need to interact with the user hands, such as identifying where the user hand is and adding an object on top of it, or different gestures with your hands, such as doing this to pinch or to zoom, or doing some magic trick or something like that. For you to get detailed hand tracking data, you do need to ask permission for the user. Okay. Also, detailed eye tracking. If you want to know where the user is looking at, what is what is the user doing with the user's eyes, you do need to ask for detailed eye tracking permission. Okay. And people can deny your request to access hand position data, for example. So as a developer, you need to be prepared to handle situations where the data isn't available. So if I'm developing an app that requires to understand where the user hand is, I do need to ask for the user permission, but I need to also create a scenario where the user doesn't give me that permission. Okay. So, and you must present an immersive space to actually access hand data. When you open an immersive space, the system hides other apps from you. Okay. I'm going to explain what is this immersive data right now. So, throughout spatial computing, we can say that now spatial computing beyond the screen boundaries, a spectrum of immersion. So spatial computing actually gives us a more spatial computing interacts with our surroundings, right? So we do have a lot of ways to interact with a user. Basically, we have three types of screens, of views, of interactions, you can say. A window-based, which is basically I put my headset and now it appears a window in front of you. There will be some examples. That's the window one. You do have volume, which is my window doesn't need to be a 2D thing, a 2D view. It can be a 3D thing. So your view now can be kind of a box. Okay, you can interact with the user not only through views, but with with a volume. Now you have height, width, and length. Okay, and you also have the immersive space, which is when you completely forget about form-based, window-based views, and then you can interact with the surroundings of the user. You can get the user into a full immersive space. Okay, and in spatial computing, besides the app state, it's what we called, which is volume, windows, and the immersive environment. There are two other types of spatial state. There is the shared space, which you can see views, just like form based, and you can have multiple windows around you. So at my left side, I can have my Safari opened. Here, I can have my, I don't know, Xcode opened. On the right side, I can have the Slack. On the others, above me, I can have my WhatsApp. Below me, I can have my YouTube opened. So it's a shared space, okay? And the full space is when you go to your headset, you go to Vision Pro and said, hey, Vision Pro, I want to take care of the user's surroundings. I want to interact with everything around the user. Okay. So what is the shared space? In the shared space mode, your app can share the user surroundings with other apps, or your own app can have multiple windows. And also apps can interact with each other. In this video right there, you can see the perfect example. So the lady is talking through FaceTime with two coworkers. She has their Keynote app open in front of her, and on the left side of the Keynote, you have the Messages app open. So you can see over there that when she opens the Messages, she can grab an image and just click and drag into the Keynote, and Keynote will interact with it. So apps can communicate with each other. All right. So spatial computing, what is the full space? In the full space mode, your app takes control of the user's surroundings entirely. You can plot, you don't have any other apps open, And for in this example, that one is pretty good. This woman, she plots a huge screen in front of her, and if she wants, she can just make her apartment go away and be on top of a of Mount Everest, for example, which is the virtual world, the virtual reality. So that's the full space when you take advantage of the surroundings of the user. Okay, you can dim light. That's what I meant. You can be in a lake. You can plot 100-meter screen in front of you. There's no problem. You have a really good screen in front of you that you can interact with. Okay. So about layout guidelines, what changes as a developer? What should I be worried about it? Okay, so what we have today in matters of layout guidelines, we are very used to it. We have a navigation bar at the top, we have a title, we have on the right side a navigation button that gives us the sense of moving forward. We have on the left side a back button with previous page label, so you can go back, and below it you have a list, you have a form-based view where you can interact with the user. Okay, those elements, they are still present in the spatial computing, the spatial era, but you do need to pay attention to some other stuff. So right now we are not going to use solid patterns anymore. We're not going to use a plain white or plain black or plain bluish color as a background, okay? Because you can't. We have to understand that right now we're not doing plotting a screen in something that's physical and I can just easily throw it away. Okay, now, and it's small. Now our development needs to take into consideration that I have a huge space and that I need to see through the view. So that's why we should use glass material instead of solid patterns. Okay, with the glass material, you kind of blur the behind of the screen. So you can have a sense of transparent. Okay, you have a sense of a glass material. So that's really important, not to use solid patterns. Okay, and some layout device, which is take advantage of the space, but keep in mind that we don't know how is the user environment. We don't know if he's in a small room, if he's in a big room, but with a lot of furniture around him, so he can't walk very easily. Right? We can state that apps can be more dynamic now. We can have big screens, small screens, more narrow screens, taller screens. Okay, so our interface now changes a lot. Okay, content position now affects a lot ergonomics. We have, again, we don't have a screen, a physical screen. Now if I add a screen in front of the user, that screen will have the user attention. Don't place content behind the user. The user will not see unless you need, unless your app demands it. But don't put screens behind you, okay? The user will not expect anything behind him. Contents that are placed too far away from the user, they tend to be less important, okay? So watch out when placing elements lower than the user vision line. So try to add elements in front of the user, not below their eyesight, not and above. The user will see, but try not to add things lower than the user eyesight, okay, vision line. Also, now we can create hierarchy with depth, the Z index, right? You have the X, Y axis. Now you have the Z axis or the Z index, okay? And most important first, it's not what we have today that something is placed in front of something. It's really in front of something. You know, if you have a message window in front of your screen, you have to understand that if you have your screen here and another screen here, the user can go on the side and look into it. Okay, so keep that in mind, and also use scale to define the importance of things. Smaller things has less importance, and bigger things has more importance. Okay, and try to invest in user comfort. All right, don't make fast movements. Avoid fast movements because if something just goes sliding really fast in front of you, probably the user won't see that. Okay, use more fading animations. All right, fading animations is something really good for the eyes, and it's very relaxing for the user. All right, and also try, of course, use recognizable items. So the heart for favorite, the up arrow for sharing, the three dots for more options. Okay, that's something that we're bringing from the old layout. So we're almost over, but there's a hypothesis that's really important to talk about, which is the uncanny valley. What is the uncanny valley? The uncanny valley, it's imagine this chart that on the y-axis, it measures the user affinity to an object, to a digital object, okay, to a digital object. And the x-axis is the human likeness. What does that mean? What is actually the uncanny valley? The uncanny valley started to be explored when that movie Polar Express was released. Okay, so when people went to see the movie Polar Express, which is a 3D movie, okay, doesn't it uses real actors just to capture their movements, but everything was 3D rendered, and the main thing of the movie was we're making 3D and trying to be the humans in the movie more human likeness than any other movie produced because we can capture human movement. There were real actors, if I'm not mistaken, I think it was Tom Cruise or Tom Hanks, that was the actor of the movie. But quite a few people left the movie with a strange feeling of the movie. The movie is really good, but some people when they got out of the movie theaters they were like I didn't like the movie, there was something wrong, I don't know what to say, but I just didn't felt quite right in the movie. I remember when I was seeing that movie that my father was like there's something, he was saying that there was something wrong with the movie, he didn't felt very comfortable with the movie. That's actually the uncanny valley. What is the uncanny valley? You can see here in this chart that when you try to make something more human likeness, something more human like, it it tries to increase our affinity. But at some point, your brain, when looking into a character or into an object or into something digital, your brain kind of say, hey, I don't feel very comfortable with what you're looking at because it looks very human, but there's something I cannot understand. Maybe it's the eye size, the face conditions, the hair, the head size. I don't know. There's something that doesn't feel quite human. Like, so as a brain, I will tell you to, hey, watch out for that. That's not human, but it looks a lot like human. So you have the uncanny valley here. It's where the affinity of that object drops completely, and the person doesn't like that. Why don't we have that feeling with anime or DreamWorks presentation, Disney presentations? because when you look at those characters, they're definitely not human. They have big eyes, and we know humans doesn't have those eyes. They have a ball-shaped head, and we know humans doesn't have that, at least not that I've seen. So we can the brain can't can look at those characters, say, let's say Moana or that girl from Frozen. The brain looks at that and say, "Oh, that's definitely not a human. You're fine with that. I don't know what it is. It's just a cartoon. We're good. There's no threat on it." But when it looks something that it tries to be human, but the brain realizes it's not, the brain says, "Hey, there's something wrong over there, bro. Don't go there. I don't feel very comfortable with it." That's kind of defensive uh, thing from our body. Okay, but after the uncanny valley, you have a really high affinity, which is when the brain can't say if that's digital or that's a real human. You can reach high levels of affinity. People will like that character, will like that illustration. Okay, so that's the uncanny valley. The uncanny valley is when you have an object, usually a person, that tries to be human-like, but if it's not perfect enough to be a human, and it's not a cartoon. So the brain said, "Hey, watch out with that." Why am I talking about the uncanny valley? Because I don't know if you guys watched the presentation from Vision Pro. It has a really cool feature of recording the environment, recording scenes. Okay, and there were quite a few YouTubers where when they were testing, they were reproducing the video of a father singing "Happy Birthday" to their children in the child's birthday. Those YouTubers, they stated that they felt something weird. They felt like, "Oh, hey, that's not my child. There's something wrong here." So right now, when we are talking about spatial computing, we have to understand that we are binding now the digital world with the real world. And if you don't work well enough in this intersection, you might end up in the uncanny valley. Okay, so you either do my advice, okay, you either go for a complete cartoon style object, or you have to put a lot of effort to go over the uncanny valley and do something really good. Okay, so that's the uncanny valley. We need to as a developer in the spatial computing world, we need to watch out for that. All right. So I want to show you guys really quick, okay, because I know we already reached more than 1 hour of webinar. I want to show you guys really quick what is how it is to code for Apple Vision Pro. Okay, just one thing, I want to be able to run the code. I will show the code. I will show the result of the code, but in video. Unfortunately, due to policy and security reasons, my M1 is reserved for my client, so I could not present the webinar using my M1 MacBook. Right now, I'm an Intel-based computer, so that's why I won't be able to run. But I can show the code and show the code result. All right, that will be really quick, and then we can move on to questions. All right, so I'm gonna open right here just an example code. So this is a project that I opened just to show how it is to code for Vision Pro. All right. This is the entry point for the app, which used to be our app delegate. It's way more fancy now. We don't have all those useless methods. No, just kidding. They're not useless. Basically, we stated that it's the main, so it's the entry point for the app. And right here we have just like a regular Swift UI project, all right? But we do have some quite interesting elements here. We do have a window group that handles a content view, and we have immersive space with the ID immersive space, which handles an immersive view. This app I'm going to show you guys, this is the result of the app, all right? So this is a screen recording of that code running, and this is the recording of the simulator. So when you are developing for Vision Pro, you don't actually need the Vision Pro. It's not even available for us, but you can use the simulator to run your app. The simulator, of course, there are some limitations such as hand gestures. You can capture hand gestures. You can't interact with it. It's just kind of a game, okay? So, for example, here I'm running. You can look around. You can walk around the room, okay? And right here, you have the home button where it's a button on your Vision Pro where if you press, it's kind of the home button for the iOS, where if you press, you can see the menu, you can see your desktop. So the mouse, it's like the hand tracking, or the eye tracking. It tries to imitate that. You can select different environments. So this app will add a drum set and a guitar. So as it was kind of big, I chose that kitchen to work with that. So that is the form, right? That's a view. You can interact with it. You can place it anywhere you want on your surroundings, all right? And I have 3D objects in my view, so you can, if you look in the sides, you will see that 3D object. And once you click and that button, show immersive space, it will add into your real world the drum set and the guitar. Okay, and if it was a real world, you could interact with it. You could see the behind. You could see behind the acoustic guitar. You could see behind the drum set. All right. So that's what this code I'm showing to you guys will reproduce. All right. And later in the video, you can also can also share that you have the shared space here. You have Safari opened, and you have the app I just coded here. So in order for me to create an app that it's a form, and if I click on a button, I can use the user surroundings. How is this code? So you have the window group, which handles the content view. The content view is the form you're seeing. Okay, it's this form right here. All right, and if I see here, I just the intention now is not to teach you guys how to interact with Vision Pro. Okay, I just want to show you the code. Okay, I think the Reality Kit itself, it's a single webinar should be made just for the Reality Kit. Today, I just want to introduce to you the spatial computing and the Vision Pro. And just for you to be aware how easy it is to code, this drum set and the guitar right here that you can see, this form right here, it's, let me find, okay, this form right here, it's this screen where you have a 3D model element that you just say, hey, can you load a file called guitar and drum set? And once you have that loaded, you please make it resizable, because as it's real life scale, that form would be huge because it's trying to load a drum set, which is pretty big. And try to to maintain the aspect ratio fit into the area you have available. And while it doesn't load, because it takes some time to load, please show a progress view, which is exactly what happens in the beginning when the app launches. You can see that right after the app launches, it's loading the 3D object. You already have the button here, but once it loads, it appears the 3D model, okay? And this is inside a vertical stack. So every element I place here, it will be placed in a vertical way, all right? And if I use the toggle button, which is this one over here, it's saying show immersive space. It's going to change this variable, which is just show immersive space variable, okay? I'm going a little bit faster just for time's sake. And I start to watch when the show immersive space variable changes, and when it changes, I look into the new value. If it's set to true, I open an immersive space called with the ID immersive space. So what does that actually means? That means that when I do this, the iOS will look into immersive space with the ID immersive space and will run that immersive space, which right here is the immersive view. So what is actually the immersive view? The immersive view, it's my surroundings, it's my immersion, it's the spatial area that I can interact with. So in this video, when I click here, all my surroundings are now my immersive view. And for this immersive view, I say, hey, can you try to load an entity, a 3D entity called guitar and drum set? So it's a file, okay, this file right here. So this is the file it's trying to render. It's just a file that has a drum set and the guitar. So can you try to load this? And it's asynchronous, okay? It takes a while to process it. So can you try to load the guitar and the drum set? And if you do, please print into the console will add content. I like to use emojis, okay? Judge me, but I like to use emojis, the console. And so in the content, which is my surroundings, can you please add the scene that I just loaded? And there goes. That's what the magic. That's when the magic happens. Okay. And Fred, hey, how you did this drum set and the guitar? You can use this app called Reality Composer Pro, where you can create, you can design, you can create models, you can use already preset instruments, such as if I want to add, for example, the earth here, I don't know what size it's going to be. So it loaded, oh, I think it's going to be pretty small. So it's downloading the earth here. So this is this Reality Composer Pro. It's a software where you can use to interact, manipulate, and develop 3D scenes. Okay, virtual reality scenes. And then you can export into USDZ files. Okay. So that's what I had in mind to make an introduction into the Vision Pro, the spatial computing era. So now we are open to questions. Does anyone have any question? Let me check this chat if we have anything. Okay. All right. So anyone has any questions?
I don't see any in the chat, but yeah, I think we don't have question, Fred.
Okay. All right. So guys, thanks for everything. It was a real pleasure to talk with y'all about this. Spatial computing is here. You're going to say something, Valerie?
Yeah, we have one question.
Okay.
But what about security? Could you explain more about this?
Okay, security. That's a really good question. People are worried about security, such as, for example, if I'm in an app that a marketplace app, for example, and I'm listing items. Okay, so what we have today in the using a computer is if you pass your mouse over an item, there might be some analytics that gets that data and sends to a, a data warehouse or a data lake saying, hey, users tend to pass the mouse over this product. What the first question we see is, why don't we use the same logic as I don't have any privacy, and if I look into an object but it's really expensive and I really want that object, but it's expensive and I don't even want to know more about it, so I don't click, I don't interact with it, but I looked into it. All right, you can say that, will there be any companies that will actually track that data only by looking at it? First of all, Apple, it's really serious with its security. Okay, you can see iPhone is a secure device to use. Okay, and Apple is doing the same thing with Vision Pro. All right, for you to get those kind of data, you need to ask the user permission for that. Okay, just a simple hover won't give you the data for that. But if what I want to say is, as a developer, it's not going to be easy for me to get their eye tracking from the user. Okay, it's not going to be easy for me to start to use the data from the eye tracking. And the same thing as the user surroundings. So if I'm an app and I'm a bad developer, okay, and I want my app to track the user surroundings, I want to know what the user have in their home. If they have a nice guitar, they have a nice computer, if they have a nice TV, if they have the latest generation video game, if they have money, I won't be able to do that. I want to be able to, as a developer, I want to be able to understand the user surroundings. I want to be able to see the user surroundings. Okay, I can use anchoring, which is anchor object 3D objects into places around me. But I won't be able to see, as a developer, I want to be able to get the data of what the user is seeing in their surroundings. Okay, if I want to do that, it's a video. I'm going to start recording a video, and just as the iPhone, an icon will appear that, hey, there's an app, and this is the app. Vision OS will say which app is recording your screen. It's seeing what you're seeing. Okay, so for security reasons, I don't know if I answered your question, but for security reasons, it's okay. I'm not worried about it because Vision OS will have a lot of protection for that. As a developer, you won't be able to see the user surroundings. That's out of our league. Okay. Any other questions?
We have one more. What is the most interesting use you can imagine for the Vision Pro?
That's also a really good question. So there's a company called Cypro, which they make 3D objects for the human body. Okay, so they make the human head with perfection. They make bones. They make organs. They make blood vessels. They create human body parts using 3D technology, AR technology. And today, this company is used by hospitals, okay? So if a surgeon wants to understand, to prepare for surgery, they are already using headsets, VR headsets, to see the human anatomy, to see the human body. All right. Not today. It's not possible for you yet. Today is not possible yet for you to see the patient's body in a 3D world, but you can see a handmade 3D body. So that helps surgeons to prepare for surgeries. Okay, there are some researches already taking place. Myself, I try to read some MRI files and try to add those files, those informations into the 3D space. So what is really exciting for me for this technology is that in a few years, I'm saying 1 or 2 years, to be honest, doctors will be able to analyze in a 3D environment the human body, the patient body, and it will move around, zoom in. Okay, doctors can already do that, but in a 2D screen, in a flat screen, it doesn't have the same result. Okay, so there are some researchers, there are some things that it's already in place for that, and I think that's what surprises me the most. Okay, uh, to use this technology in the medicine area and also for the work environment. I can have multiple screens available for me. I don't need to stick with a small 2D screen, have multiple monitors. I can now use my surroundings for that. And for housing is also really good for architects to build their environment, to show their client their new house. It's also pretty interesting. But to be honest, spatial computing, it's something that we will require to use more of our innovation thoughts to work with it. Okay, we need to be more innovative. We need to understand that it's an area that needs more innovation, but not from the technology, from ourselves.
Nice. Thanks, Silvia, for your question. I think we don't have any more. Only message that the presentation was great. So you rock it, Fred. Well, thanks everyone for joining. We will share the record of this webinar so you can have it if you want through our social media. One more time, thanks, Fred. You rock it.
Thanks, everybody. Appreciate everybody's presence. Belu and Jenny, Mika, thanks for all the help, for all the patience with this presentation. You girls were really awesome. And thanks everybody for attending. It was a pleasure talking to y'all.
Thank you so much, Fred. It was great. Congrats.
Thank you.